Dear students, today we are going to discuss between the force between 2-point charges in position vector form. Suppose we take here 2-point charges in space. That means in a coordinate frame of reference OX, OY and OZ. This is a three-dimensional coordinate frame of reference. Suppose Q1 is the charge here at A and Q2 is the charge here at position B. These two charges are separated by a certain distance. These two charges at the time we say these are the like charges and they repel each other. Here the force is F21 and this Q2 applies force on Q1 as F12. This Q1 is at a position vector R1 from the origin and Q2 is at a position vector R2 from the origin. The distance between A and B is AB. Let me suppose when Q1 repels Q2 with a force F21 given by Coulomb's law. That is F21 can be written equal to 1 upon 4 pi epsilon naught Q1 Q2 upon distance from here to here I will write as AB square and this direction is from A to B. I will write as AB cap. Let I say this as first. This AB cap I will calculate first from the triangle. In triangle OAB, according to triangle of addition of vectors, I will write as OA, vector OA plus vector AB, you will get it as OB. OA plus AB is equal to OB, or vector AB can be written equal to vector OB minus vector OA. OB और OA को माइनस कर लेंगे. This OB is equal to R vector. R2 vector minus OA is equal to R1 vector. This AB. The magnitude of AB can be written equal to mod of R2 minus R1. This magnitude means AB. But at the same time, total vector AB can be written equal to it as two parts. Magnitude part, AB is magnitude, AB cap is its direction. I will write this as AB cap equal to vector AB divided by AB magnitude. So this equation 1 can be written, therefore equation 1 can be written as F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon AB square into, instead of AB cap, I will write this vector AB divided by AB magnitude. This AB vector I will write here as, let me say the second. So I can write it as F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon AB square into, instead of AB I will write as OB minus OA vector divided by AB, which can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon AB, and AB square becomes AB cube into OB minus OA, or it can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon, इस AB का वैल्यू यहाँ से निकाल दिया हमने, R2 माइनस R1 का मैग्नीट्यूड whole cube, here it is cube not square, cube, whole cube into OB minus OA is equal to R2 minus R1 vector. This is F21. This equation you will call as third. Similarly, we can write when Q2 repels Q1, when Q2 repels Q1 with a force given by, with a force, that means by Coulomb's law, given by F12 equal to 1 upon 4 pi epsilon naught Q1 Q2, here it will be equal to R1 minus R2 magnitude का whole cube. By same process जैसे ऊपर हमने किया वैसे यहाँ पर भी कर लेंगे. It is R1 minus R2. This is equation 4th. From equation 3rd and 4th, we observe that here from equation 3rd and 4th, we have F12 is equal to minus times F21, because R12 cap is equal to minus times R21 cap, or so we can write here R12 cap is along this way and R21 cap is along this way. So here again we observe that the Newton's law holds good here. These are the Newtonian forces. Then comes the next is the superposition principle. Superposition principle states when number of charges interact with each other, the net force on a given charge is equal to the sum of the forces between the given charge and all other charges, as given by, suppose we have a charge Q1 here and it is surrounded by number of charges and number of charges. Let me say Q1, Q2, Q3, Q4, Q5, Q1. Suppose these charges individually interact with this charge. This is a given charge Q1. Q2 interacts with this Q1 with a force like this. We can write it as F12, force on 1 due to Q2. Q3 repels Q1 with a force F13. Q4 repels Q1 with a force F14. Q5 repels Q1 with a force F15, and so on. Qn repels Q1 with a force F1n. The net force on Q1, that is, let me say F1 equal to F12 plus F13 plus dash 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 plus F1n. This is the superposition principle. The total force is equal to force between the given charge and all other charges, their sum. Let me call this as first. But according to Coulomb's law, when Q2 repels Q1 with a force F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon distance from Q2 to Q1. It is, let me say, R square, rather I can write as R2 1 square into R2 1 cap, 2 to 1. This is second. The force between Q3 and Q1 is F13 is equal to 1 upon 4 pi epsilon naught Q1 Q3 upon R31 square R31 cap. Here these unit vectors R21 or R31, these will show the direction of the force wire to wire. Q2 to Q1, then Q2 to Q3 to Q1. Similarly, for nth charge, for force between Qn and Q1 is F1n equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R n1 square or n1 cap. This is, let me say, this is nth equation. We take all these equations from second to n, substitute in first. Therefore, we can write F1 is equal to 1 upon 4 pi epsilon naught will remain common everywhere, and within the bracket you can say it is equal to Q1 Q2 upon R2 1 square R2 1 cap plus Q1 Q3 upon R 3 1 square or 3 1 cap plus dash 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 plus Q1 Qn upon R n1 square or n1 cap. This is the total force. Similarly, we can write other forces between, suppose Q2 is now the given charge and all other charges are interacting with Q2. At the time we can say, the total force on Q2 by all other charges is given by F2 can be written equal to F21 plus F23 Q3 plus F2 4 plus dash 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 plus F2n. That means 2 is now given charge. Here Q1 was given charge. Here Q2 is given charge, surrounded by all other charges. Therefore, we can write F2 can be written 1 upon 4 pi epsilon. Here it will again remain common. It is Q2 Q1 upon Q21 square Q21 cap plus Q2 Q3 upon R23 square R23 cap plus dash 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 plus last valley term we can write Q2 Qn divided by R2n square R2n cap. This is F2 force, and these are all what we called as the statements confirming the superposition principle. Okay, this is all for today.